Hello, statistics students. So we are going to get into hypothesis testing about proportions, hence the title. But first, I want you to just try the warm-up. It is from chapter 17, so the one that we just did. So see if you can check the conditions, be very specific, construct your confidence interval, and then explain what the confidence interval says about chicken sold in the U.S., which is a little gross because it's about bacteria. But anyway, take a minute and do that, and then after you're done, it will be open, and I'll have the answer. Okay, so hopefully you can see that. There are 525 people. That's less than 10% of all, or I guess it's broilers. Less than 10% of all the broiler chickens in the United States. 436 and 89 are both greater than 10 because those are your success failure. Your confidence interval is 79.8% to 86.3%. And then you're 95% confident that between 80 and 86% of all broiler chickens in the U.S. are infected, which is, again, yucky. So we have talked about this before, but I wanted just to remind you about the fact that if you end up with something that is greater than 2 standard deviations above the mean, then it's called statistically significant. We talked very briefly about that. Okay. However, in this case, we know that our p-hat is actually going to be within 2 standard deviations, which means the company can't conclude that the process is improving. So, for example, if you found out that your standard deviation of your sample was way beyond what they assume that the p-value is, the true proportion, you'd be able to tell that there's some kind of change. So it would be like them collecting this data about, they're called ingots, and they're part of a machine, but they said that on average the proportion is about 20% that are cracking, but then they took another sample and figured out that it was about 17%. So it's not a huge change. In fact, overall they're kind of doing worse. Oh no, I guess they're cracking, so it's less of them are cracking, but not enough to show that it's a huge change. So if you saw that it was 2 standard deviations or more above or below the mean, you'd say like, oh, this is their process of the ingots is changed. So that too is super important in this case because it again shows a significance level. All right, testing a hypothesis. So there are a few things that you have to check. The first thing is the null hypothesis. So what that looks like is HO, okay? What that means is literally null hypothesis. Hypothesis. That means it's an assumption that nothing has happened. Assume nothing changes from the original. Okay? Number 2 would be to model. Okay, so you have to check the assumptions and conditions. Assumptions and conditions, basically to model the normal model, like what we're used to doing. You have to check to make sure you can use that normal model. The third one is mechanic. So basically you want to calculate what happens and see if the data looks surprising. So calculate and reflect, basically. And we'll see what that looks like later. And then finally, have a conclusion. So in this case, is this just because of sample-to-sample variability? So again, if it's greater than 2 or less than 2 standard deviations above the mean, then we know it's significant. If it's not, it's just regular variability amongst each sample. Okay? The other big key difference with null hypothesis that we're not used to is we reject the null hypothesis if it's 2 standard deviations or above, You don't ever accept a null hypothesis, so you would actually say fail to reject if it's not above 2 or below 2 standard deviations, which is very weird for us. But it basically just means you can't guarantee that it's going to be exactly right if we're sampling data. Okay, here's our first example. So they're talking about the motor vehicle department is claiming that 80% of candidates pass driving tests, but a newspaper reporter surveyed 90 randomly selected local teens who found that they only had 61% that passed. So you basically want to figure out if this DMV has a lower rate than the larger cities. So in this case, this would be like, this is our P, and the 61 out of 90 would be our P hat, because that's coming from our sample. Just to state a null hypothesis, an actual hypothesis, this is the null. So basically you're stating that our sample is no different than the true proportion, so P equals 0.8. And then the alternate hypothesis would be whatever the change is. Take a second and see why they did less than 0.8. So you can see it says is lower than the DMV reported. Is our true proportion going to be less than 0.8? And it says I'll assume that passing rate for teenagers is the same as the overall 80%, unless there's strong evidence that it's lower. So again, if you're over 2 or less than 2 standard deviations above or below the mean, then you would reject your null hypothesis and state that this is probably a true statement. Okay, see if you can just write your null hypothesis. Use the correct notation, please. Again, it's very similar to the last one. You're pretending like your 75% is your p-value. So see if you can write your null and alternate hypothesis, kind of like what we did up here. Just be careful, it says they want to see if the new version of the drug works even better. That's key phrasing in there. Alright, so hopefully you recognize that your null hypothesis is that your proportion is the same, it's 0.75. Your alternate hypothesis is going to be that your proportion is greater than 0.75. And again, if you were to test that and you figured out your standard deviation above this average, this is basically your average, if it was greater than 2 or below 2 standard deviations, you could say that we would reject our null hypothesis and assume that this drug probably does work better than 75% of people, for 75% of people with the allergies. All right. So, one proportion z-test. This is going to be in your calculator a little bit, and if you have trouble doing this on your own, I can show you later as well. A lot of this is going to be done in your calculator, but there's also formulas. So, what I want you to notice is there's slightly different notation on these now. So, p hat is what we calculate. This is your null p, meaning like your true proportion. It'll make a lot more sense when we use our examples, but that null is basically like the true proportion for anything. Notice that they said when it's a hypothesis, they just use different notations so you don't get confused between that and what we did in the last chapter. The z-score is basically the same as what we've always been doing. Just notice again the different notation. Okay, again you have to check the conditions like standard. Again, check for randomization. Check that your sample is less than 10% of the entire population and the success failure. You don't have to check for independence only because they're not talking about multiple samples. Okay, so we're gonna do the example. You can do this with your table partner if they're on the same spot as you, or you can wait a second and see if they can get to yours. I want you to try it out first, though. Check all of your conditions. That's all you're doing right now, and then again, I'll have the answer in a second. Ooh. Okay, so I'm just going to verbally tell you this because otherwise it's a lot of writing. Make sure you state that it's a random sample. You can say that 80 is less than 10% of all allergy sufferers. We expect 60 successes and 20 failures. If you don't know how to get that, you would do 0.75 times 80 for our success, and that would be your greater than 10. And then your failure would be 0.25 times 80. That's also greater than 10 because it comes out to 60 and 20, and that means we're okay to use the normal model. Okay, so we are back to the DMV scores. You get 80%, that's always your P, just as a reminder. So that's your true proportion of all drivers. What we want to do is figure out what the z-score is. So you need to figure out your standard deviation first, which you use your P. Obviously that would be your failure, so they have success rate of 80%. They have a failure rate of 0.2 and it's over 90. I want you to make note that your standard deviation in this case of p hat is actually using P in it, not p hat, so just be careful on that. And then your z-score is p hat minus P, so they got the 0.678 from doing the sample 61 over 90, minus your P, so minus 0.8 over your standard deviation, so they get negative 2.9. That shows significance because it's less than 2, so that means that you can say the driving rate is probably going to be less in this sample than in most cases because it's usually 80%, and that's way below 2 standard deviations. I want you to try number 3, see if you can find p hat and the z-score. Again, just be careful with your z-score to calculate your standard deviation. Okay, so then you should get your answer of your p hat is going to be 69 over 80. Your z-score is going to be 2.39. And how you calculate that is you basically want to take p hat, you can look at the formula above, but p hat, if you put it in your calculator, is 0.8625 minus p, which is 0.75. Then you have to do it over your standard deviation. Standard deviation, just be careful again, is going to be 0.75 times 0.25 over 80. So if you plug that in, you end up with 2.32. The only other thing to mention is the null hypothesis. So you never accept the null hypothesis, you always fail to reject if you decide to say it's okay, because it's kind of like with our 95% confidence rule that you're not going to be 100% right or know that it's 100% perfect because every sample is going to be a little bit different. So we say either reject your null hypothesis or fail to reject. So again, you're not rejecting it. All right, we're going to get into a little bit more. Okay, so now we're talking about the DMV, but they gave you the z-score this time, so they said they figured out the z-score was negative 2.9. So what can you conclude? So because your standard deviation is less than 2, you would reject your null hypothesis. Remember, your null hypothesis would state that your true proportion is 0.8, and that would be true for any sample we have. But if you reject that, you're saying that there's strong evidence that the passing rate is going to be less than 80% because it's a standard deviation that's negative, but also because it's greater than or less than 2. Okay, see if you can make a statement about 4 and 5. Again, they give you a z-score, and then you can figure out what you can conclude from that. So pause the video, figure it out, and then when you're done, you'll have an answer up. Alright, so my niece is here to help you figure it out. That's Chloe. So number 4, the z-score is greater than 2, so we reject our null hypothesis, which means the new meds are probably better. Whereas number 5, the z-score is not greater than 2 or less than negative 2, so it lacks evidence to show any kind of difference. So basically you would fail to reject your null hypothesis, which means that there's no change from the true proportion. Alright, now it's time to take out your calculator. Bless you! That's going to be in the video, Margot! No, it's okay. So we are testing a hypothesis now, and that's a slightly different spot than what we did last class. So now we're doing a one proportion z-test. So we're not doing confidence interval anymore, so that's why you have to go to z-test. So you're going to go to the same spot we did before, which is stat in your calculator. So go to stat, tests, and then the one proportion z-test is number 5 in your calculator. Make sure that you have your screen looking exactly like what's here. So if they're, it depends on what scenario they're talking about, but in this case, they're saying that your alternate hypothesis is that your score is going to be greater than your null, because they were trying to figure out if this percentage is actually better than the one that they thought they were going with. So this would be like your p hat almost. And they're trying to figure out if it's greater than your null hypothesis. So then you go to calculate, it actually gives you your z-score, it gives you, this is your, just be careful, this is your probability, this is p hat, the 0.54, and then it gives you the sample size. You can also do a 1 proportion z-interval, which we did before, now that you know your p hat and all that jazz. But the 1 proportion z-test gives you your z-score, your probability, and your p hat, which we didn't have before. Okay, so this is probably the most challenging part of this whole chapter, is figuring out the two different errors that could happen. So there's a type 1 error and a type 2 error. Type 1 would be like if they're testing out a drug and they somehow figure out the drug is actually the same as what they originally thought, but then they report that it's actually better. So this is actually the worst type, is a type 1 error, because they're basically lying to people, whereas type 2 is they just mistakenly report false information. So it would be like the drug is actually better than before, but they somehow report that it's not better. So it would actually be worse for the company if you have a type 2 error. So again, type 2 is the drug is actually doing better if they're talking about a drug, but they report that it's not better. So they did that same thing with the DMV. It would be a type 1 error if the DMV claimed it's actually correct, but the reporter writes a false story. And then type 2 would be they state that there is no change when it's actually lower. So see if you can check out number 6. It's basically the same idea. I kind of already answered it for you above when we're talking about a drug, but see if you can figure it out for yourself for number 6. Okay, so again, type 1 error would be they state that the drug is better than the original drug, but it's not, so it's like lying to clientele. But then B would be like it's actually better and they mistakenly say it's not, so it's like detrimental to the company. Alright, so there's something called a two-tailed test. Okay, so the 3 types are either two-tailed test, which would be like your alternate is just saying your proportion is not equal to what it originally said. The lower-tailed test would be, in this case, where you have, obviously, your P is going to be lower than what they originally said for the true proportion. And then the upper-tailed test would be, obviously, the opposite of that, and it would be if it was greater. Oops, I circled the wrong thing. If it was greater. Okay, so for the example that they want you to do, they just want you to figure out whether it's going to be upper, lower, and two-tailed test, or two-tailed test, and then figure out what the null and alternate hypothesis would look like. This is going to be kind of challenging, but try it out first, and then I'll show you the answer after. Okay, so the first one is lower, so your null hypothesis would be that P equals 0.6, so your alternate would be that it's less than 0.6. Letter B would be two-tailed, because it's just saying it's not equal, so your alternate would be that it's not equal to the proportion, and then upper, again, would be greater than for your alternate. Just make sure you're using the correct notation for null and alternate. Alright, so one of the last things we're looking at is alpha levels and critical values. They're very similar to looking at your z-score. I just wanted to show you that the alpha level is basically your probability of this happening. So if you think about it, within 2 standard deviations is your 95% rule. So a one-tailed test, if you look at the visual for it, would basically just be if your z-score is 2.33, it would be either above by 2 standard deviations or below. Either one is one-tailed. The alpha level is 0.01 because this is close to a 99% confidence. So the remaining value is going to be 0.01. Same thing with 95%, so that's why that's here, and then this would be a 90% confidence level. So the z-scores kind of match. The two-tailed level would be because it's the area between them. whereas one-tailed is on one side or the other. So you don't really ever have to use that, but it is an alternate that you might end up seeing if you take stats in college. And then the last thing we're looking at is the probability. What I want you to be careful of is that they use probability as a capital P, so it's not talking about a proportion in this case. So this is different from, like, little p is the proportion, big P is probability, okay? And it talks about that here too, but we find the probability of you getting a certain percentage. If you forget how to do that, for example, they're talking about the DMB problem again. They got a z-score of negative 2.9. So you can see the visual here, but just remember to get the probability of a z-score less than negative 2.9 in your calculator, you do normal CDF, negative 99 to the z-score, and then hit enter and it'll give it to you. I also want you to read the statement that comes with that. So it says if the passing rate for teenage drivers really were 80%, we'd expect to find a success rate this low in only 2% of samples. So p-value this small, strong evidence that the passing rate for teens is lower than 80%. So just so you know, if you have a p-value that is less than 5%, you're actually going to reject your null hypothesis. Because it's such a small percentage for a probability that you can see there's going to be evidence that it's going to be lower. So it's basically showing, like, these are the same thing. You don't have to do both, find the probability and the z-score. You already knew that this z-score would tell you that it's going to be rejected. Just know that if you also get this, it's like reassuring. You're kind of confirming it in two different ways. All right, last thing I want you to check out is the question 8 and 9. See if you can figure out what those p-values mean. Again, if you get less than 5% for a proportion, you reject your null hypothesis. And what does that mean about your sample? So take a sec, pause the video, and I'll show it in a second. All right, so number 8, you're only getting 3 out of 100, so it probably will show an increase. Again, that's less than, this p-value is less than 5%, so you would reject your null hypothesis, and that means that there's a change between your proportion and your sample. Whereas 9, this is greater than 5%, so you would fail to reject your null hypothesis, meaning if it shows an increase, it's probably due to sampling error. So there's probably not a change in it at all. All right, folks, if you finish early, feel free to move on to your mini project. Otherwise, have a great rest of your day.